Welcome back to Bits and Bytes. We are continuing our conversation talking about complex data types in Python. Today's video we're going to be focusing on sets. We did release an introductory video covering the basic data types in Python, things like integers, floats, strings, and booleans. If those sound like foreign concepts to you, it might not be a bad idea to pause this video and go back and watch that basic data types video first. It's kind of like the foundation upon which we're going to be building this house of data. So anyways, today we're talking about sets, what you can do with them, what you can't do with them, what some of their main advantages or disadvantages are. If you have any future content that you'd like to see, go ahead and leave it in the comments below, as well as if you have any feedback about this video, definitely would love to hear it. With all of my videos, I do leave in the description below, there is a link to the Google Colab notebook. And so if you would like to follow along, or if you would like to just have that to reference back to from time to time, go on ahead and click that link. You can download the notebook and just have access to it anytime that you need it in the future. So again, thank you so much for watching Bits and Bytes. We're going to go on ahead and get started talking about sets.
Test your might.
Continuing where we left off before, talking about data types in Python, the focus for today's video is going to be on sets. Now, real quick, if you haven't watched it yet, I did release a prior video covering the basic data types in Python. So if you are not familiar with booleans, integers, floats, and strings, go back and watch that video. It's not a super long video, but it does cover all of these topics in one video, so you have a better understanding of some of the more fundamental concepts when it comes to Python data types before you start diving into some of the more complex data types and more complex relationships that those data types might have. So again, if you haven't watched it yet, go back and watch that video now. But we are going to go on ahead and pick up where we left off, talking about complex data types in Python, focusing on sets. Creating a set is very straightforward. In this example, we're creating my_set, and we're creating it using the curly braces, just like I mentioned above, and we're populating this set with coffee, bacon, apples, coffee, bacon, apples. However, when we print my_set, we're going to see the resulting set is just apples, bacon, and coffee, and that is because sets are comprised of distinct elements. So even though we're specifying some duplicate values here, Python automatically strips those when we create our set, because we can only populate our set with distinct elements. Sets also provide for very fast membership testing, and all membership testing is checking to see whether or not something exists in your data. So in this case, we're checking to see if coffee exists in my set, and we can see that the returning Boolean value is true. Coffee does exist in my set. And the next example, we're checking to see if bacon exists in my set, and it returns false. Why does it return false? Bacon does exist in my set. It returns false because this membership testing is case sensitive, and so if we want this to be accurate, we would actually have to capitalize the B in bacon, rerun it, and then we'll see that the returning Boolean value is true. The membership testing for sets is fast simply because if you think about a list and you think about how a list can be populated with a bunch of bloated duplicate data, if you just want to check to see if something exists in that list, which might have millions and millions and millions of rows comprised of a lot of different duplicate data for various purposes, you can simply take that list, you can convert that list to a set, it's going to strip out all of the duplicate values and then perform your membership testing on that set. That resulting set might only have thousands of rows instead of millions of rows, and that is going to be a much faster membership test than performing the exact same membership test on a list. Okay, and in this next example, basically all I'm going to be doing is reinforcing the fact that sets cannot contain any duplicate values. So if we use the mySet.add method and we try to add coffee to my set, coffee already exists in my set. So when we print that, we're going to see that all we have is coffee, apples, and bacon, all distinct elements. We can't add coffee to it because coffee already exists in it. If we create another set and we call that mySet1, and mySet1 is comprised of 5 singular ones here, and then we print mySet1, we can see that it's just a singular one. There are no duplicate values. Further, if we create a list and we call that list accounts and we pretend that these are all just a bunch of pseudo account numbers and there are a bunch of duplicates here, if we wanted to quickly get rid of those duplicate values and only have resulting data that is our distinct elements that are contained within our accounts list or accounts data, we can just convert that to a set, and we'll see here that the resulting set is all of the unique and distinct elements from our list accounts. Test, 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 test. Next, we're covering the various set methods that are available, and we already covered add above, but myset.add dog food basically just adds dog food onto your set. So we can see that we now have my set including apples, bacon, coffee, and dog food. .discard removes a specified element from your set. So if we ran that code, we would actually remove dog food from my set. So our set now is apples, bacon, and coffee. .pop will delete a random element from your set. So first we're going to add dog food back in, and then we're going to print my set before the pop, and we'll see that my set before the pop is coffee, dog food, apples, and bacon. But then when we do my set.pop, we can see that my set after the pop is dog food, apples, and bacon. And it truly is random. So when you do .pop, it's just going to choose an element from your set and just delete it at random. All right, so next we're going to talk about set operations. And set operations include union, intersection, difference, and symmetric difference. These are mathematical operations, so if you've completed high school level math or even maybe intro to college algebra or something like that, you've probably covered these topics before. They are also very similar to some various join criteria that you might see if you are used to querying data using SQL or SQL. And so we'll use some SQL examples as we go down below and progress through this section. However, I'm also going to be using some graphs as examples, and I just want to point out that the purpose of this section isn't to teach you how to graph in Python or create plots in Python. So don't focus a lot of your effort on understanding what's happening in this plot code. If you want to know what's happening there, just check out matplotlib, look up a video on matplotlib. I'll probably create a video at some point talking about matplotlib, but for now, don't worry about what's happening in this code. We're just going to use the Venn diagrams to reinforce some of the concepts that we talk about as they pertain to set operations. And so for this example, we're creating set A and we're creating set B. Set A is integers at the 100 interval. Set B is integers at the 50 interval. And if we create a Venn diagram of set A and set B, this basically is going to show us how many elements are individually and uniquely in A, how many elements are individually and uniquely in B, and then how many elements are in both. So first, if we look at how many elements are in both, we can see that there's 3 elements that are in both A and B. And if we look up here, we can see that that translates to the 100, the 200, and the 300. The 300, 200, and 100 are in each set A and set B. If we look at this part, we can see that there are 2 elements in set A that are not in set B, and that would be the 400 and the 500. And then if we look over here, we can see that there are 3 elements in set B that are not in set A, and that would be the 50, the 150, and the 250. And so that's basically how you interpret this Venn diagram. Next, we are going to look at the union of set A and set B, and the union of set A and set B will return all of the unique values that appear in both sets. So basically, it's just going to combine set A with set B, and it's going to remove any duplicate values. And that is the mathematical union of these 2 sets. And you can use mathematical notation in order to get that union, or we can use the dot notation method down below to get that union. Regardless of which method you go with, it's going to generate the exact same result. Looking at the intersection of set A and set B, the intersection returns basically which values appear in both A and B. It's like a join or an inner join for SQL people. So with the intersection, it's basically going to return only these values here, whichever values are in both A and B. So right in the middle there. And we can see if we do set A intersection set B using the ampersand here or the dot notation below, it's going to return 100, 200, and 300, and that is the intersection of set A and set B. Next, we are looking at the difference between set A and set B, and this is kind of like subtraction, so you don't want to necessarily overthink this, but I've reprinted our sets here just so we have visibility into it and we don't have to keep scrolling up and scrolling down. And basically, if we do set A minus set B, or we do set A dot difference set B, using the dot notation, all this is saying is what is in set A that's not in set B. So if we look at set A, what is in set A here that's not in set B? Well, 400 and 500 are in set A, and 400 and 500 are not in set B. So the resulting set is 400 and 500. Alternatively, if we do set B minus set A, we can see that we're asking what is in set B that's not in set A. So 100, 100, 200, 200, 300, 300, those are all in both. But 50, 150, and 250, those are contained in set B, and they are not contained in set A. And so that would be the resulting set when we do the difference of set A from set B. All right, I have another example here that I want to share, and this example basically uses sets that are comprised of strings. And so this example with set A and set B, the sets are comprised of integers, and when you do the difference here, sometimes people get confused. They think you're doing subtraction, you're subtracting 50 from 40 and this and that, and why is this the answer versus like 400 minus 50, which is 350. So this can get a little confusing, but when we use strings, it helps to paint a little bit more of a clear picture. So set X is coffee, creamer, and sugar. That's one way to take our coffee. Set Y is coffee, milk, and stevia. Set Z is coffee, caramel sauce, and steamed milk. So if we do set X minus set Y, what is in set X that's not in set Y? Let's see, coffee is in both. Creamer, nope, that's only in set X. Sugar, nope, that's only in set X. So when we do the difference of set Y from set X, the result is creamer and sugar. Creamer and sugar are in set X, but they are not in set Y. Alternatively, if we do set Z minus set X, we'll see that the result is steamed milk and caramel sauce. So steamed milk is in set Z, it's not in set X. Caramel sauce is in set Z, it's not in set X. Coffee is in both. So this is the result when we take the difference of set X from set Z. And then we created a Venn diagram here basically just to reinforce that. Coffee is the only element that is in all three sets. And then aside from coffee, all of the other individual elements are only contained in their own unique sets. So this guy takes creamer, this guy takes milk, this guy takes steamed milk, this guy takes sugar, this guy takes stevia, this guy takes caramel sauce. So we can see that coffee is the only intersecting element between set X, set Y, and set Z. All right, last example here is the symmetric difference, and this one's pretty straightforward. Basically, the symmetric difference tells us what is in X and what is in Y, but what is not in both. It's kind of like an outer join. So it shows us what's in X, it shows us what's in Y, but it does not show us what is in both of them. So if we look at set X is coffee, creamer, sugar. Set Y is coffee, stevia, and milk. And so what do we have here that's in set X that's not in set Y? And what do we have here that's in set Y that's not in set X? Well, we have creamer and milk in set X, and those are not in set Y. And we have stevia and sugar in set Y, and those are not in set X. To complete the symmetric difference, you just use this caret symbol here, or you can use the dot notation, where we would say set X dot symmetric difference, and then set Y.
Flawless victory.
And we just wrapped up our lesson talking about sets. Thank you so much for watching. If you have any questions, go ahead and leave them in the comments below. If you liked the content, please don't hesitate to hit that like button and subscribe to the channel. Like I said, we do release content weekly, focusing on various analytics topics. So thank you so much again for watching. Have a great rest of your day. This is Bits and Bytes, and we will catch you next week.